Well, aloha and welcome to Flow of Control 2. We're going to talk about loops. I'm going to try to make this a little quicker because you guys are getting a little more experienced and you don't need so much explanation. So let's get right into it. So today we're going to talk about how to perform repetition of statements using the while do, for, and the do while loop, and we'll give a bunch of examples. And we'll talk about sort of a modification of this called the for loop and when you'd want to use that over the others. Iteration is the way that you repeat a statement multiple times, and the way it tends to work is you have a loop control, which is going to be a conditional expression, and anything within this block is going to be repeated until the loop control goes false. There are three different forms of iteration that are pretty common: the while, the for, and the do while. They basically are all variations of the same thing. So anything you can do with a while you can do with a for, and anything you do with a for you can do with a while. You can always convert one to the other. It's just which is more convenient for what you're doing. So a while loop basically says that it's a conditional statement. That means that, again, like an if statement, you have this thing, it's not a function, but the keyword while, and you have to have the parentheses, and in there is a condition. And as long as that condition is true, the statement is going to be executed. When it's false, the statement does not get executed, and it goes on to the next statement. For loops are a variation of that. For loop is where you start at a particular place and have a condition for where you end and describe how that is incremented. And what happens is these three things work together to say repeat starting here while this is true until and change it according to this. In a while loop, you're responsible for changing the increment, but in a for loop, it does increments for you. So in terms of a while loop, you could write a for loop as the same thing. You start out the condition while this condition is true, you do your statement, and then you do your increment, and then it just keeps repeating this until this condition is false. Do loop is the same thing, except for that instead of checking the condition first, it actually does the statement, executes the statement first, then checks the condition. So a while loop checks the condition and only repeats it while this is true. This one does the statement first, then does it while the condition is true. So this ensures that the statement is executed at least once. And so the way to do that, the equivalent form is by just doing the statement first and then doing a while loop. So let's look at the basic while loop. That's a certain basic thing. It just says that, again, while this condition is true, execute this statement. And what happens is you keep executing it until it's no longer true, or a break is executed. So break is another keyword that will, regardless of whether the condition is true or false, it will stop repeating it if it gets a break command. So here's an example. It says x, you set some values and we do a while $x is greater than 0, and in here we're just going to add x to a running sum. So s starts from 0 and we're just going to add x to it, which starts out at 5, and then here's our incrementer. It actually is going down, so x starts out at 5, now it goes to 4, and then it goes 3, 2, 1. And then what happens is when x is no longer greater than 0, so that when x equals 0, this condition is false, and this block does not get executed anymore. What happens is that x starts out at 5, and s is at 0, so s now becomes 5 at the first execution of this. Notice that when x is equal to 5, 5 is greater than 0. That's true, so that gets executed and that gets executed. Now, this is x minus 1, so x was 5. Now, after I reassign it, x is 4, and I go up here, 4 is greater than 0. That's true, so this gets executed and that gets executed. Now, x is 3, 2, 1, 0. 0 is not greater than 0, it's equal to 0, so this would be false, so these no longer execute. The upshot of all this is that s becomes the sum of the numbers 5 plus 4 plus 3 plus 2 plus 1. Let's try that out. doing a reformat just to make it look nice. Again, like with the if statements, when you're under the control of a while condition, you traditionally indent things over to the right to show that these two statements are under the control of that while. Notice that because they're in the parentheses here, or the curly braces, that both of these are things under the control. If I had put the parentheses here, or I didn't put the parentheses, let's just take the parentheses out, and I reformat, you'll see that now this is no longer indented because it's not under the control of the while anymore. So be careful about where you put your curly braces. It's always a good idea that even if you only have one statement, just to put the curly braces in there just to make it clear. And more often than not, if you have to modify your code, you may end up adding an extra line. So what we'll end up here saying is we'll print $s. We'll say here x is $x and s is $s. So if I run this, you see x is 0, s is 15. X started out at 5 and it went to 0, 5, 4, 3, 2, 1, and s is 15. It was 5 plus 4 plus 3 plus 2 plus 1, which you can convince yourself is 15. We went down with x, but there's nothing stopping us from going up with x as our incrementer, and you can also change the condition so that it stops when it is greater than a certain value. So that's sort of counting down. Now we can count up. So here we start with x equals 1, s equals 0. Okay, x is equal to 1, 1 is less than or equal to 10. That's true. This is true. Therefore, this gets executed and this gets executed. S is 0. 0 plus 1 is 1, so 1 gets assigned to s. S is now 1. X is 1. X plus 1 would be 2. Assign that back to x. Now x is 2. Go back up to the top here. 2 is less than or equal to 10. That's true. And now we do it again. Now we have 1 plus 2. So now 1 plus 2 is going to be 3, right? And now x is 2. 2 plus 1 is 3. Assign that to x. X is now equal to 3. Come back up to here because we're at the end. 3 is less than or equal to 10. That's true. 4, 5, 6, 7, 8, 9, 10. Now when we get to 10, x equals 10. 10 is less than or equal to 10. That's true. So this gets executed again. Now x is 11. X comes back up to here. 11 less than or equal to 10 is false, and we stop executing. So you can try this code if you want. And I just do a reformat here. And I run that. And you see x equals 11, s equals 55. It's important to realize that at the end of this loop, I'm not at 10. X is going to be 11 because I have the equal sign there, right? So x actually is 11. It's one more than where I end at. It's very common to make a mistake on where you end the loop. If I make that less than and I run it, you notice that no, I've got to take that out. Notice that it says that x equals 10 and s equals 45. Make that a little bigger so you can see it. Now, notice if I put that x is greater than or equal to 10, what's going to happen is I'm going to get an infinite loop, because what happens is that x starts out with, it was not going to get an infinite loop, it's going to get an empty loop, because x equals 1 here, 1 is greater than or equal to 10 is false, so this stops executing, and x never gets incremented, so this ends up going nowhere. It's called an empty loop. So if I run that there, you see x equals 1, s equals 0. Not what I wanted. The condition is I want things to be true until I want it to stop being true. In this case, I want it to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want it to stop after it's not 10 anymore. So you got to remember the condition here is that this has to be true for things to continue. Moving along here, so That was an example of an empty loop. You could also do an infinite loop. So if it turns out that, let's just say, what would always be true? Well, if I had something like here, x is greater than 0, well, 1 is greater than 0. That's true. So this executes, yes? And now x is 2, goes back up through 2 is greater than 0. 3, 4, 5, 6. It's always going to be greater than 0. So this will just run forever. Now, PHP actually has a provision for this. If you try actually running this, it'll run for quite a while. See, it says waiting for localhost. And it's just going to spin. See how it's spinning here? So we're in an infinite loop. But after a little while, it'll time out. And it'll say, I've exceeded the maximum amount of execution time. It's a little bit of a protection. I hope that that's actually what's set. It might not actually be set to do that. Looks like so. If you find yourself in an infinite loop, rather than waiting, see it now, it finally timed out. You didn't see it, but there's an output here that just said that it was a maximum execution time. But you see it stopped spinning, but there was no output. If you find yourself in an infinite loop, let's just try that again. So you run that again. You can just hit the stop here. See how the X, if you just stop that there. That's one way of doing it. Of course, a simple way of getting an infinite loop is you could just say something like while true. If you say while true, it's just going to just go on forever because true is always true. While false, of course, never runs anything. It just goes right to the next executable statement. Be careful, like with the if statement, never to put a semicolon at the end of the conditional. That's really nothing because this is just going to be an empty loop. There's nothing to execute. It doesn't matter whether it's true or false. It's still going to be empty. So be careful about that. Let's take a closer look at this. If I wanted to create an infinite loop, then I could create a condition, a while condition, that says with Boolean true here, that will always execute the next statement. So it says while true, that's the condition. What should it do? As long as this is true, it's going to execute the next statement repeatedly. Well, this is always true because it never changes. So the upshot of this is it's going to repeat this infinitely. So if I copy and paste that over to here and I run it, in fact, let's just put a new line in here so we can see. Actually, no, let's not put it. Let's put a space in there and run that. You see, it just gives me an infinite number of I will do the reading assignments. You can see how it's just building up more and more and more here. And this is going to keep repeating until it runs out of the maximum execution time or memory. To stop it, I'm just going to hit the X like this, and that stops it. And you can see that I have quite a considerable number of I will do the reading assignments. So the output is an infinite number of those things, effectively. If I copy this over here and I put false in here and run this, you see that I get no output whatsoever. Why did I get no output? Well, because the condition says while false. So false means that do not repeat the next statement, and false never changes to true at any time, so the next statement never even gets executed once. So the upshot is we have an infinite loop here or an empty loop. And as I said, it's quite easy to make conditions for which you're going to get an empty loop or an infinite loop. I'll give you some examples of that as we go on. Sometimes you actually want to exit the program early, not just exit a loop, but you might want to exit the entire program early. There's no point in going on, and to do that you can use the exit or die function. If you put an argument in here, it'll output that before it exits. Let's give you an example. Now I'm going to copy and paste this. And when you copy and paste from PowerPoint, again, you have to be very careful about this smart quotes. See how PowerPoint will often use these back quotes and front quotes rather than the straight quotes. And you can see that I'm getting a warning here that it doesn't understand the syntax because it's using smart quotes rather than the straight quotes. So we need to replace those before we go on. So I'm going to take one of these guys. I'm going to do Control H, and that gives me the front smart quote, and I'm going to replace that with the regular straight quotes and replace all. And similarly, I'll do these, the back quote, and replace all. And now I've replaced all my angled quotes or back quotes and front quotes with straight quotes. That's a little better. So what happens when I run this program? Again, you have to be careful that you might get yourself into an infinite loop situation. As you see, I'm running on and on and on and on. What I actually have here is an infinite loop. Now, it doesn't look immediately obvious that it's an infinite loop, but let's just find out why. So we start out here with x equals 5, right? So I look at 5 plus plus. Well, that plus plus applies to the 5 after. And what we end up getting here is that 5 is greater than 0 is true. Now, after this x is evaluated, then x becomes 6. So we have this value is true, and x now is equal to 6. So since it's true, then this block will execute these two lines. So I get down here, I said if x equals 3. Well, x is 6. That's not equal to 3, so this doesn't get executed. And so it goes on to here, and it echoes out 5 or 6 and then a new line. Then it goes back up to the top and it gets now 6 is greater than 0 is true. X is 7. This doesn't get die doesn't work, and this just goes prints again. And you can see that what happens is that as we keep going, x increases, and it's never going to be equal to 3. It's always going to be greater than 0. It's also never going to be equal to 3, and as a result, I have an infinite loop starting at 6, and it just keeps going. Probably what we wanted is starting at 0 or 1. And if we did something like that, now you see I get I will not execute because 0 plus plus greater than 0. Well, what happens is that 0 greater than 0 is false. So even though I have the plus plus here, notice that it's done afterwards. So first I'm using it here, so 0 greater than 0 is the first thing that checks. Then x becomes 1. So first it's false, and so because it's false, these lines don't get executed at all, and so I have an empty loop. So at first I had an infinite loop, next I had an empty loop, simply by having the wrong value of the starting value for x. Now if I start at something like 1, then you see I get 2 and done, which is probably more like what I wanted. So now I got no infinite loop or empty loop, and what happened is that when x was 3, it executed the die command. The die command then terminated it. Notice that it doesn't print anything. It does not print 3 because I'm dying before I output the value when x is equal to 3. And this statement never gets executed because I'm terminating at this line. And so anything after that doesn't get executed. Now there are other ways to get out of a loop if you need to. You could use the break or continue. Now the break keyword, well, if I'm in a loop and I execute a break, it immediately terminates the loop and then executes the line after the loop. So it's a way to get out of a loop and not have to keep repeating something, even if the condition is still true. Continue, what that does is as soon as you get the continue, it stops executing anything underneath it and goes out to the top of the loop. That might increase a value or an increment or something like that, but the upshot is that it continues on from there. Let's give an example of that. So we can copy this here, paste it over here, and once again we have our straight quotes issue, so we're going to want to replace those. And then what happens when we run this? Oops, I got to put this inside PHP. There. Oh, looks like we got ourselves another infinite loop. Okay, let's see what happened here. Notice that we have the same basic code except for, as last time, we have x equals 5, x plus plus is greater than 0. That's true. X is 6. X equals 3. No, that never happens. So it's going to be 6, 7, 8, 9, 10. As you can see, that's what x is, 6, 7, 8, 9, 10. and therefore we never get to the break. So again, what we need to do to avoid an infinite loop is go down to something like 1. If we went to 0, once again, we'd have an empty loop. So let's run it like that. And now it says 2, I will always execute. The other one never executed because what happened was we did an exit or a die, which terminated the program. In this case, we just did a break. So as soon as x is equal to 3, this line doesn't execute. It goes to the end of the block and executes the next line that's outside the loop, which is I will always execute. So sometimes break is quite handy. Usually it's used within the context of an if statement, that you only break when something happens that you're checking for. Okay, and it's quite useful. What about continue? Let's copy and paste this. Like that. Once again, I have my straight quote problems, so replace those. Like that. And if I run it, once again I have an infinite loop. Oops, I forgot. Not x equals 5. We need to start x equals 1. Run it. And you see I also have an infinite loop. So what happened here? Okay, let's see. No matter what I do, I seem to get an infinite loop. Because what's going on here is that we start with x equals 1. 1 is greater than 0 is true. And then x is now 2. So x is 2, x equals 3, no, nothing. It prints out that, which is what we expect. So we get 2. Notice what happens then is now x equals 2. We go x plus plus is 2 greater than 0. That's true. X is now 3. Is x equal 3? That's true. So it goes to continue. So instead of executing this line, it goes back up to the top. And now 3 is greater than 0 is true. So the loop will execute. X plus plus makes 3 4. So x equals 4. X is not equal to 3. So that just gets skipped. And we print out 4. So you see we end up getting 2, 4, 5. So we get an infinite loop, but it skips the third one. Now a for loop is very similar to a while loop. It's very convenient for incrementing something from a starting point to an ending point. So as stated earlier, you can see that they're equivalent in terms of you can write a for loop in terms of a while loop. Let's take an example of this. How could we convert something like the program we had before, where we were summing the numbers from 1 through 5. So here's some of the numbers. It will sum the numbers from 1 through start. Sum is equal to 0. X equals 5. We go as 5 greater than 0 is true. 0 plus 0, right, becomes 0. X minus 1. Well, actually, x is 5. So it's 5 plus 0. So it's 5. So s is 5. Now x is 4. 5 plus 4 plus 3 plus 2 plus 1. So the same example we had before. We could write that exactly with a for loop by doing this. Starting out with x equals 5, that's the initializer, semicolon. Our condition is that x is greater than 0, and then that's next semicolon. And then what we do is we continue to do this by decrementing 1, by making x go down by 1. And then what we do is we notice there's no semicolon here. We will continually sum this value. So let's just see if this gives us the same values. I'm going to copy this here and copy that there. And we'll do a print quote x $x, and s is going to be $s. And then if I run this like that, you see x equals, oh, I forgot to say s there. We got x equals 0, s equals 15. So let's see if this is equivalent. I'm going to copy this, and I'll paste it like that. And now I run it, and you see I get exactly the same value. X equals 0, x equals 15. If you didn't believe me, we can try putting x equals 10 there to change things, and you see x equals 0, s equals 55. So again, that's the way the for loop works. Usually we like to have it look like this. Where does x start? continue while that's true, and how does x change. Of course, we could have done x minus minus there too. That would have been exactly the same. Here's another for loop example. You can think that other example that we gave where we counted up instead of down. Okay, same thing. Start x equals 1, keep going while it's 10, x equals x plus 1 instead of minus 1, sum the values. You can see it looks a little simpler, a little easier to read. So when you need to start at one place and go up to a certain point, end at another place, and increment it by a certain amount, the for loop is very convenient and easier to read. But it's exactly the same as doing a while loop, just some things moved around. Let's say you wanted to print 100 times that. I will not turn my homework in late. Well, you can just have an iterator. We call this the iterator variable called $I. Now, it doesn't matter what variable you use, but $I is convenient. Initialize it to 1, so we're starting at 1. Keep going while I is less than 100, and then increment I by 1. And so what the upshot is that it will print 100 times I will do my homework. I will not turn my homework in late. So let's put a BR here so we can get a new line. And we run that. And let's see if this works for us. Now when we try to run this, you may see that this doesn't work. You'll see that I accidentally added a parenthesis there. So you better delete that. And then we run that, and it says I will not turn my homework late. And this is going to do it exactly 100 times. Okay, let's just make sure that we can see that. Let's put a $I colon there, and you'll count it for us 1 through 100. In a for loop, it's very common to have an off by 1 error. So if I did less than 100, then notice that it's only going to print up to 99. So it's very common to have off by 1. Or if I start at 0, I'm going to have more than that. Okay, even though I end at 100, it's going to end up starting at 0, right? And so I end up having 101 of these things. Another common mistake is to put a semicolon at the end, and again, just like putting a semicolon at in a while loop, it's just going to print out exactly that one statement after x or I increments itself to 101. So notice that at the end of this loop, I is now 101 because that's when this becomes false. Put a semicolon here so it didn't repeat anything. This line always gets executed, and it's when I is 101. Another very common mistake to make. It's very common to have a loop that does more complicated things. You can do whatever you want in there. So for example, I could make it print out alternately my robot loves me and my robot loves me not by putting an if statement in here to allow things to change according to the loop. So we call that loop processing. So let's just take this. I'm going to make that, instead of a /n, make that a BR. And I'll make this a BR here, like that. And let's see what happens when we run this. See? It says my robot loves me not, loves me not, loves me. It's alternating back and forth because it's saying that I'm going to do this 20 times, repeat this 20 times, this loop, anything in this block 20 times, and now I'm going to use the iterator to change things. So when I is a multiple of 2, when I is even, okay, in other words, when the remainder is 1, actually this is when it's odd. When it's odd, say my robot loves me, otherwise it's going to be even, and my robot loves me not. And so I alternates between even and odd and even and odd, or in other words, having a remainder of 0 and 1 and 0 and 1 when divided by 2. And so that allows me to switch based on the value of I. So it's very common to use not just the iterator to count things and repeat things a certain number of times, but also to use the iterator in your command. Here's an alternate way I could have written that same thing. I I can echo my robot loves me and then just say, if I'm even, put the word not in front of it and tag them together. Ask yourself, which one do you think is more elegant? This version or that version? They're equivalent, but which one's more elegant? So when using a loop, you need to be careful. Common loop errors are having an off by one. You start one before or one after, or end one before or one after. So you have to check your initial conditions very carefully to make sure, and your ending conditions to make sure it begins and ends where you want it to go, whether it's a for loop or any other kind of loop. Sooner or later, everyone's going to write an unintentional infinite loop or an empty loop. Just have to kind of dig through and figure out where it is. So your first bet, if something just keeps running, it's probably an infinite loop. You can either hit the, if it's in a web page, you can always hit the stop key. If you're using something else like a console, you can hit the Control C or the stop button on the browser, like I said. You should test your loops very carefully, especially what we call the boundaries. In other words, where they start and where they end, to make sure you didn't make an off by one error. The idea of tracing a variable in a loop is to print out each variable each time through the loop. We kind of did that when we were doing the previous example with the robot, with the homework, where it printed out what is the value of the iterator, so you can see what it's doing with that value and where you are in the loop. So sometimes there are systems like in NetBeans that actually have a built-in tracing system, which we'll look later, which will tell us what value things are without having to print them out. But more than often, you have to put your own print statements in to check to see what is there. So that's that, and we'll talk more about the details of loops in class. See you there.